Okay, hello. This is chapter 3 video. This is the one on sections, let me show you, sections 3.5, 6, and 7, which is about transformations, absolute value function, and inverse function. So let's get started. I'm gonna start, but I hope you're doing well. I'm going to start by getting rid of my video and starting with a problem as usual. Now, before I do this, uh, the question that we want to answer is this question. So let me get a little white area I can write on. So what we want to answer is something like this. So if we have a function, let's say f of x equals to square root of x, this function. Now we know the graph of this function starts from 0 here and then goes up this way. That's the square root of x. Now the question is, what is the graph of, let's say we make another function and then we add to the right hand side of this. What does that do to the graph of the function? So how are the graphs of this one and this one related? And the answer is that if you add to the right hand side, the graph is like you're adding if you add it to the right hand side, it's like adding to the y coordinates of the points. So they all go up 2 units. Now, what if you subtract from the right hand side? Now, if you subtract from the right hand side, then it's like you're subtracting from the y coordinates, so they all go down 2 units. And this one is called the vertical shift up, and this one is vertical shift down. Now, we could also, what else can I do to the right hand side? Well, I could take the right hand side and then multiply it by a number greater than 1. What does that do to it? Well, that is going to stretch these points. So it's going to, let's say this y coordinate is 1, then it's going to multiply it by 2, you get 2. If this y coordinate is 2, multiplied by 2, you get 4. So you see it goes up more than this point. So this is called vertical stretch. What happens if you take the right hand side and multiply it by a number divided by a number is like multiplying by a fraction. Let's say you divide by 2. What happens to the graph? Well, this is equivalent to multiplying the y coordinates by 1/2 or dividing by 2. That means it's going to be vertical shrink. So all the y values will shrink you shrink them to half as much as they used to be. Again, the shrinking is not the same for all points. It depends on the y value. If y value is 1, then it goes to 1/2. If the y value is 4, then it goes to 2. So you see, that's the difference of only 1/2. That's the difference of 2 units. All right, what else can we do to the right-hand side? Well, we can take the right-hand side and multiply it by a negative. What does that do? That is going to change all of these y values to negative y values. So it's going to be a reflection over what? The x-axis. So this one is called vertical shrink, and this one is called reflection over x-axis. Okay, so what do they look like? So this one is going to look like that, but it's going to move up 2 units. So it's going to kind of look like that. This one right here is going to go down 2 units. So it kind of is going to look like that. This one right here, it's, if the original one is here, right? This one, the 0 doesn't go anywhere because 2 times 0 is 0. So it's going to stretch like this vertically. This one, if the original one is over here, when you shrink it vertically, it's going to look like that. It's not a straight line, it's just look like that, right? And the reflection over the x-axis is going to look like, that's the original one. That would be the reflection, right? So these are what you can do to the right-hand side, which is basically vertical transformations. These are called transformations. So we can add to the right-hand side, it moves up that many units. You can subtract, it moves down. You can multiply by a number greater than 1, it stretches vertically. Multiply by a number less than 1, between 0 and 1. It shrinks vertically. And if multiplied by a negative number, it reflects over the x-axis. Now, can we do the same thing to x? Yes, the only difference is that since we don't have, so this is y equals to, f of x is y, right? Y equals to square root of x. So basically, when we write, when you write plus 2 on the right-hand side, really what you're doing, if you write y equals to that, that's not the old y, because the old y was just square root of x. This is square root of x plus 2. So what you're actually doing is you're subtracting from y 2 units, and then if you move the 2 to the other side, that's what you get. Since we don't do it to y, but we do it to right-hand side, then it looks like whatever you do here, it happens to the graph. So if you add here, it goes up. If you subtract, it goes down. If you multiply by a number greater than 1, it would be a stretch. So whatever you do here to the right-hand side, it happens to the y coordinates of the points. But with x is different, because this is not x equals to something, so x is not on one hand side by itself. So for example, if you so really, if you think of y on the y, if you think of y, then y, really what you're doing, you're subtracting from y when you're adding to the right-hand side. You're actually subtracting. If you add or subtract from right-hand side, you're actually adding to y. If you're multiplying by 2 on the right-hand side, you're actually dividing y by 2, right? You see that? Y equals to square root of x, right? So if I divide it by 2, then cross multiply, the new y would be what? Would be 2 times the square root of x. So in the formula, if you do something to the variable itself, not to right-hand side, but to the variable itself, then what happens to the graph is the inverse of that operation. So if I subtract from y, actually the graph goes up. But we don't do it this way because we already have y equals to the right-hand side, so we're not going to do it to the y in the equation. We're going to do it to the right-hand side. So that's why we don't say for y, for vertical transformations, we say whatever happens here is exactly what happens to the points, right? To the y coordinates of the points. But when we talk about x, so if I want to, let's now talk about x, right? I'm going to move up in a wide area over here and talk about x. So it's the same function, right? So it's the same function. square root of x, right? And now we want to do, so this is our f of x. Let's call it f of x. Now what I want is a function, right? So g of x is going to be square root of x plus 2. Now the question is, how are the graphs of this one and this one related? And the answer is, since we are doing it to x, to the variable, then what happens to the points is just the inverse of this. And the inverse of addition is subtraction. So that means if you add to x, then the points will go to the left, because in reality you're subtracting from x coordinates and they move to the left. So we call this function, which in function notation you can write it as f of x plus 2. That's what that is. And this is called horizontal. Now, since it moves to the left, we call it horizontal shift, right? But to the left, right? So if you add, it goes to the left. Now, what if we do x minus 2, which is f of x minus 2, right? That means in f of x, you substitute x minus 2 for x. That's what you're going to get. Now, again, since you're doing it to the variable itself, what happens to the graph is the inverse of what happens here. So this goes to the right 2 units. So we call it horizontal shift. Horizontal shift to the right. And what happens if you multiply x by a number greater than 2? I mean greater than 1, let's say 2. Well, again, what happens is the inverse of this operation. What happens to the x coordinates here? You take all the x coordinates and divide them by 2. And this is going to create a transformation we call horizontal. Remember, if you divide by 2, they move to the left. That means you're shrinking, right? So this is called horizontal shrink. It's not the same as shifting to the left. It's just that all these points are going to be shrinking, not the same, or the same factor. So it's not like shift, you move it to the left for 2 units. So this one moves to the left more than this one and this one and this one. So it's going to be shrink horizontally. So that's horizontal shrink. And what happens if you divide x by a number, which means multiplying by a fraction? So like f of what? F of 1/2 x. Then you have something called horizontal stretch. So that means this means that x coordinates of the points are going to be multiplied by 2 if you divide the variable here by 2. And lastly, we can multiply the variable x by negative, and that is going to cause a reflection over the y-axis. If you make all the x's negative, you get all the points move to the other side of the y-axis. So that is called reflection. So it's a reflection over y-axis, over y-axis. Okay, so what do they look like? Well, this one is going to look like, so if you have the original graph here, then, well, that doesn't look good. see if I can make it straight. So if the original one is here, you move to the left 2 units. So that's the new graph. And this one, if the original one is over here, and the next one is going to be, this graph is the graph of square root of x minus 2. And the horizontal shrink is going to look like this. So if this is the original one, when you push this way, shrink it, well, it's going to look like kind of this, right? Well, kind of like this. And horizontal stretch, if the original one looks like this, the horizontal stretch, if you stretch it to the right, stretching it, that's what it's going to look like. And reflection over the y-axis is going to look like this. Kind of like that. Well, made a mess there. So kind of like that, okay? So these are 10 transformations. These are transformations that are the results of doing something to x, and then those that we talked about before are transformations that are results of doing something to y, to the right-hand side. Not exactly to the y, but to the y variable, but to the right-hand side. So that's why these transformations, whatever we do here is exactly what happens to the points, and the transformations right here, whatever we do to the x variable here, the inverse happens to the points, okay? So in general, if we have, is good to think of just f of x. Let's say this is f of x, right? So when we have a function, let's say 3 square root of x minus 1 minus 4, right? Now, this is a combination of these transformations. How do you know what transformations we have here? Well, you have to know the original parent function. So here we know the parent function is square root of x, right? So what has happened to it? Well, think of this part as, so think of a point on this function, well, not there. I graphed all of them except what I wanted. Okay, so here we go. So suppose we have a point on the graph and the x coordinate is a and the y coordinate is f of a, right? Okay, so we call that a and f of a, right? Now, when we go through this transformation, what happens to a general point on this function? What happens to a, which is the x coordinate, and what happens to the y coordinate? We can easily tell over here. What happens to f of a is easy. Just think of f of a as what? As this right here, the part that has the function. So what happens is that you multiply it by 3 and subtract 4. So it's a vertical stretch by a factor of 3 and a vertical shift down by a factor of 4. So that means this new point is going to look like this. The y coordinate is going to go to 3 times f of a minus 4. Now what happens to the x coordinate is tricky. Remember, what happens here is the inverse of what happens to the points, and if we have more than one transformation, then it's tricky to see what transformation we have here. So the easy way to do this is to let a equal to whatever this expression is here. And then solve for x here, isolated on one side. Now, once you solve for x, you know exactly what happens to a to get the new x. This x would be your new x. So the new x is the old x plus 1. Now, you can easily graph this. How do you graph this? Well, you can easily think of a bunch of points on this. Let's say 0, 0, this point, and some other point, like 3 points, and then use this to transform those points and then graph this, right? You can easily tell the transformations here. If you multiply f of a by 3, so basically what you have to do is first you have to do a vertical stretch by a factor of 3. Then you have to do a vertical shift, right, by 4 points, right? And then, so these are vertical, and the horizontal transformation is only what? Is a horizontal shift to the right or to the left? Well, to the right, because you're adding to the x-coordinate. From the formula, we know is minus means you add. But once we figure out what happens to this general point, then everything you see here is actually happening to the x and a y coordinate, right? So adding 1 to the x-coordinates is a horizontal shift to the right. So we separate the vertical and horizontal shifts. And notice that there is an order to it, right? So you don't want to subtract by 4 and then multiply by 3. You multiply by 3, then subtract by 4. So the order has to be exactly the order of operations here. That's the order of transformations. Same is true here. So if you have, 3a, let's say I have 4a plus 1, then I have to multiply by 4 first and then add 1. So that's the idea. Now, to understand it a little bit better, I'm going to open up a program to show you the animation of these transformations quickly. So here is the program. So what I'm going to do is I'm going to open this program. And you see, here is a function in algebra. You don't know trigonometric function. So I'm just going to change it to what? X to the power of. Now, a square root of x is x to the power of 1 over 2, right? 1/2. So that's that, right? So that's the function. So what I'm going to do, I'm going to first do vertical shift. So I'm going to change this. You see, as I change this number, which is what? Which is this number d, right? Which is a number I added to f of x, and f of x is that. So as I change that number to positive numbers, what happens? You see the graph just moves up, right? See, like the graph of the square root of x plus 2.6, it looks like this, except has moved 2.6 units up. If I make this negative, it just goes down, as you see, right? So that's the vertical shift. Now, what about vertical stretch? Well, vertical stretch is when I multiply this number, when I multiply the right-hand side by a number greater than 1, which is b in this case. So notice that b right now is 1, so it doesn't make any changes, doesn't make any difference. But as I increase it, you see, all the points get what? Stretched vertically. Notice, for example, this point goes up this much, but this point goes up way that much. That means these points are stretched proportionally depending on how much the value is, right? So it's not like shift. You see, I turn on the shift. You see, the shift of that much, 1.6, is like all the points are going to move up 1.6, but the stretch is different. See, it's proportionally. All right, so what about vertical shrink? Well, the same kind of idea. Vertical shrink, if it's 1, doesn't change anything. But if I multiply it by a fraction, let's say 0.7, and then all of these points will be multiplied by 0.7, right? And you get this green one. All right, what about reflection? Well, if I multiply the right-hand side by -1, like that, then all these y coordinates will be negative. So you get a graph like this, right? All right, so what about horizontal shift? Well, horizontal shift, is either to the right or to the left. You see, for example, right here, I'm adding 2.8, so the graph moves to the left 2.8. If I subtract, let's say 2.3, it moves to the right 2.3. All right, so that's the horizontal shift. And horizontal shrink and stretch, I do it in one step. So you see, if that number is 1, it doesn't change anything, right? See that? So if I multiply x by a number greater than 1, which you see right there, if I multiply it by a number greater than 1, notice that we get a horizontal shrink. So all of these points will shrink this way, right? You shrink them this way. Okay, so what if it's a number less than 1? If it's a less than 1, let's say 0.6, all of these points get stretched this way, right? So that is horizontal shrink and stretch. And then reflection over y-axis, if you multiply, see right here, if you multiply x by negative, then it reflects over the y-axis. Now notice that this is a square root of negative x, so the domain of it would be negative x values. So under the radical will never be negative because the domain is negative numbers. And if x is negative, negative times negative is positive. All right, so now let's go back to doing problems. So the first one we're going to do, it says write the formula. So let's get, if this video becomes too long, I may do another one for the other sections, but let's see. So it says write a formula for the function obtained when the graph of f of x equals to square root of x is shifted up 1 unit and to the left 1 unit. So we know the original function is square root of x. So what we want to do, this new function, we want to shift it up 1 unit and to the left 2 units. So shifted up 1 unit, that means I have to add 1 to the right-hand side of this. And shifted to the left 2 units, that means I have to add 2 to the x coordinate. Right? So in terms of f of x, that's written like this. F of x plus 2 plus 1. That's what this new function is. So you get the old function, input x plus 2 for x, and then add 1, right? Okay, so that's the answer to number 6. Now, next one I want to do is number 8. Is this one. It says write a formula for this function is shifted down 4 units and to the right 3 units. Well, again, here's the function. So you have to subtract 4 from right-hand side. And then since it's shifted to the right 3 units, you have to subtract 3 from x, right? See that? So that's an easy one, just like the one I just did. Okay, so let's do number 18. It says the graph of f of x minus 7 is vertical shift. Oh, it says explain what this transformation is in number 18. So what is that transformation? Well, we talked about that, right? We said, let me get this so we can talk about it. So we said that if you start with this whatever function, it doesn't matter whatever it is, what is going on here? What transformations do we have? We have a vertical shift up, and we have horizontal shift to the right. It doesn't matter in what order you do the transformations of y and x. So if you do x transformation first and then y, doesn't matter. They're independent of each other. But if you have many y transformations, you have to figure out in what order you have to do them. The same is true for x, in what order you should do them. And the formula tells you in what order. Now here we only have one of each, so there is, no order involved. So it doesn't matter which one you do first. So it's a vertical shift, right? Up, how much? 3 units. And then horizontal shift to the right, 2 units. So the graph of f of x minus 2 plus 3 is horizontal shift to the right, 2 units, and a vertical shift up, 3 units. The 3 is missing here. Okay, so that's number 18. So let's do, well, number 19 and 20 as well. Well, look at number 19. Well, again, is shifted down 1 unit and what? And move to the left 4 units, okay? All right, what about number 20? It says in the following exercises, determine the intervals on which the function is increasing and decreasing. All right, so let's do, we're gonna do number 20. We have enough space up there to do it. Yeah, so the parent function for this is x squared, right? So let's call it something else, because we just call it g of x, because this new function is called f of x. So f of x is actually what? What transformation? Well, is you get the x, let me write it here. So you see, we're going to think of this as what? Think of this as the right-hand side. So what happens to it? So if we have a point a and g of a on the original graph of what? X squared. So let me graph the original graph here. So it would be will look like this, right? All right. Now I'm going to put 3 points on it. I'm going to put 0, 0, and I'm going to put 2 more points. Let's say 1, 1, and negative 1, 1, right? Now, how do we graph this if we have these 3 points? Well, let's see. So if there's a point on g of x, a and g of a, what happens to it? Well, we know what happens to g of a. What happens to g of a? You multiply it by 4 and subtract 5. So 4 times g of a and subtract 5. So that's the x coordinate and that's the y coordinate of the old points, right? So what happens to x? Again, we said to get the x, don't just put a plus 1. That's not right. You have to put a equal to x plus 1 and solve for x. So x is going to equal to what? A minus 1, right? So a minus 1. So to graph this, we're going to take these points and see where they go. 0, 0, 1, 1, and negative 1, 1. So where does this go? Well, let's see. 0 minus 1 is negative 1. And 4 times 0 minus 5 is minus 5. Okay, so let's call this A, B, C. And we call this A prime, which is basically what happens to A under this transformation. And what about 1, 1? So 1 minus 1 is 0. And then 4 times 1 minus 1, 4 minus 1, 4 minus 5 is negative 1. And what happens to this one? Well, what's negative 1 minus 1? Well, that's negative 2. And what's 4 times 1 minus 5? Again, is negative 1. It goes to the same place as this one. Okay, so we call this B prime and we call this C prime. So we want to graph this. Now, first of all, before you start graphing the points, make sure you have enough space on the x and the y. So on the x-axis, we need from negative 1, negative 2, negative 1, and 0. So it's negative 1, negative 2, and 0 we got. Okay, on the y, we need negative 1 to 5. So it's negative 1. This is negative 1, and 5, let's say, is negative 5 over here. Right? So negative 1, negative 5, negative 1, negative 5 is like this point right there. Let me erase this 5, put it on this side. So it would be this point right there, right? And 0, negative 1, 0, negative 1 is right here, right? And negative 2, negative 1, negative 2, negative 1 is over here. So notice this shape right here. That's why I named them A, B, C. So this is A, right? I mean, this is not A. Oops. All right. So this is A, right? 0, 0 is A, 1, 1 is B, and the other one is C. So notice that I have to connect A prime, right? So A prime goes to B prime, and A prime goes to C prime. So this is A prime, right? So I have to connect it to that, kind of like this. And this continues this way. And then this continues that way, kind of like that. Now, this is not the shape of it I don't like. So this continues this way. And this kind of goes like this, right? Not a very good quality graph, but it's correct, right? Now notice that I didn't mark anything on the y-axis here when it crosses because I don't know what it is. I have to figure it out. And I don't know where it crosses on the x-axis. Now we can find out because we have the formula. So let's find out. So f of x equals to 4 times x plus 1 squared minus 5. So where is the y-intercept? Well, y-intercept is easy to find. Just let x be what? 0. So f of 0 is going to be 4 times 0 plus 1 squared minus 5, which is what? Well, that's just 0, because 0 plus 1 squared, right, is just 0. I mean 1. 1 times 4 is 4. 4 minus 5 is negative 1. Looks like it is negative 1 right here. So it's kind of correct, right? And what about x-intercepts? Well, we have to let y equal to 0. So to find the x-intercepts, we have to let f of x equal to 0. So 4 times x plus 1 squared minus 5 equals to 0. I keep forgetting the parentheses. So that means 4x plus 1 squared equals to 5. And that means that x plus 1 squared equals to 5 over 4. So let's have some room here. So x plus 1 has to be plus and minus square root of 5 over 2. I have to take a square root of what? Both sides. So x is going to be either positive square root of 5 over 2 minus 1, or positive square root of 5 over 2 plus 1. I mean, not plus 1. All right, so or what? Or negative, look at this. This is not cooperating. So it's going to be negative and then minus 1. There's a negative here, you see it? A negative there. So it's going to be negative square root of 5 over 2 minus 1. Now square root of 5 over 2, square root of 5 is like 2 point something, divided by 2 is like 1 point something, minus 1 is point something, which is this point right there. So this is that point right there. And then the other one, that's a negative 1 point something, minus 1 is negative 2 point something, which is this point right there. So that one is that point, right? So using transformations, we can easily see what happens to the original points under what? Under this transformation. And this is what happens to them. You can graph more points if you want to, and you can easily graph it. All right, so that was number 20. And let's do another one. So in this set of problems, it says, for the following exercise, use the graph to sketch a graph of each transformation of f of x. Now, we don't have to know how to graph 2 to x. You're just given the graph. You just have to use the transformation to graph them. So let's do number 20. Let's do number 26. What's number 26? So it says the original graph, so let's do that, this one. So let's get some white area. So the original graph here looks like, this. This is what we are given. So this is 1, this is at the up there. I showed you that graph, right? So that's the original graph, which is, again, you don't have to, let me put it down here. So you don't have to know how to graph this. This is 2 to x, right? Now, what was the name of it? The name of it was, what was the name of it? Let me see what the name was. The name of it was, well, let's see. So the name of it was f of x. Okay, it was f of x. So let's get, where did it go? Here you go. All right. All right, so we want 2 to the power of x minus 1. So this graph, compared to this graph, has moved to the right 1 unit. So we're going to get a point on this graph, let's say 0, 1, which we are given. And also looks like this has a horizontal asymptote. That means this graph is approaching what? Is approaching this line, which is x-axis, right? And x-axis is nothing but what? Y equals to 0. So y equals to 0 is the equation of x-axis. Everywhere, all the points, the y is 0. So I have to graph this right here. Well, to graph this, we have to shift the right 1 unit. So all we have to do is what? Take this point 0, 1 and move it to what? To 1, 1. Right? Now, nothing else changes. This horizontal asymptote doesn't change. We are not moving up and down. We're just going horizontally, so it stays in the same place. So that means on the left, it's going to look like that. And on the right, it just goes up like that. So that is what? 2 to x minus 1. Again, we have a whole chapter that we're going to talk about this kind of functions, exponential functions. You know, like COVID-19, it's actually exponentially increasing in the world and in the US. You see, it looks like that. We are trying to make it look like that, flatten the curve. Now in Houston area right now, we don't know where we are, we're somewhere over here, but we are going to get to that point sooner or later, in 2 weeks, in 3 weeks, and then after that, still people are going to get sick and unfortunately die until we flatten the curve. We are about 2 months late in controlling, in containment and mitigation. We did a little bit by closing the flights coming from China, but we should have done social distancing 2 months ago to stop this, make it go down. But anyway, so that's how you graph these. All right, next I want to do number 27. Well, it's similar to the one I just did for you, right? We can do it again quickly. So what I'm going to do, I'm going to use that graph that we have here, which is the graph of correct answer. But what I'm going to do, I'm going to first put, let's say we have g of t, the original graph, which is t squared, right? That's the parent function. So t squared is over here, right? So t squared is kind of like that. That's where t squared is going to be here, right? Kind of like that. So if we take this 0, 0 point, where does it go? Well, again, we know if we have a point on we have a and f of a, where does it go? Well, it goes to, think of this as what? As our old y, t squared. What happens to it? Well, you multiply nothing to it. You don't multiply by anything itself, just minus 3. So it would be f of a minus 3. And what happens to the t input? We're going to let a be t plus 1 and solve for t. What do we get? We get a minus 1. So 0, 0 will go to where? 0, 0 will go to 0 minus 1 is negative 1, and 0 minus 3 is negative 3. And exactly that's where it has gone. See, negative 1, negative 3, right there. So that's where this one goes. Then you can graph the other points to graph it. Let's say 1, 1, and again, negative 1 and 1. Where do they go? Well, 1, 1 goes to, not equal to, goes to where? Well, 1, 1, 1 minus 1 is 0. So it goes to 0, right? Because 1 minus 1 is 0. And what's 1 minus 3 is negative 2. So you see 0, negative 2 right there. That's where this one goes. And then this one goes where? That's negative 1, 1. That goes to, what's negative 1 minus 1? Is negative 2. And what is 1 minus 3? Negative 2. So it goes to negative 2 and negative 2, which is right there, right? So that one goes there. And then you graph it. Again, x and the y-intercept, we have to what? We have to figure out what they are. The y-intercept is easy. If you put a 0 here, you get 1 minus 3, which is negative 2. So that's the y-intercept. And for the x-intercept, just take t plus 1 squared minus 3, set it equal to 0. So t plus 1 squared is 3. So t plus 1 equals to plus and minus square root of 3. So t is either square root of 3 minus 1, or t is negative square root of 3 minus 1. Square root of 3 is about 1.7 minus 1 is 0.7, which is that point right there. And negative square root of 3 is negative 1.7 minus 1 is negative 3.7, negative 2.7. And negative 2.7 is right there. Okay, so you see that transformations are helping here a lot to graph these. All right, so let's do a few more. Let's do number 34. Let's see. I'm going to do a variety of these problems. So number 34 is, what is number 34? What are we supposed to do? It says, what are we supposed to do? It says, for the following, write an equation for each graphed function by using transformation of the graphs of the toolkit functions. Toolkit functions are the parent functions. So we want to do number 34. Here we go. So how is this graph transformed? Well, let's see. We can kind of look at some points. For example, this point right here looks like is 0, supposed to be 0, 0. Where is it now? Is at 1 and negative 3, right? So that means 0, 0 has moved to the right 1 unit and has moved downward 3 units. Now there are other, could be a little bit more complicated, like we have to know the x-intercepts as well, but for now we're going to guess that this would be the original x squared, right, that has moved to the right 1 unit and then down how many? 3 units. So if I want to move it to the right 1 unit, I have to subtract 1. And if I want to move it left 3 units, I have to subtract 3. So we guess that this is the answer. We are given another point here to check whether we are right or not. For example, this point is what? This point says that if x is 2, y is negative 2. Does it work? If I put a 2 here, does that make y negative 2? Yes, because 2 minus 1 is 1. 1 squared is 1. 1 minus 3 is negative 2. So that's the correct answer. All right, so let's do a few more. I'm going to do 40. Let's do a variety of these. Which one should I do? Let's see. 47. Here we go. So for the following, it says determine whether the function is odd, even, or neither. Now, we're going to talk about even and odd functions quickly, and then we do these three together. So even and odd functions, basically if you have a function that is symmetric with respect to y-axis. Symmetric means what? Means that if you pick any point on this graph and you connect it to the y-axis, you're going to find another point on the other side with the same distance from the y-axis. So you have to draw a perpendicular with a 90-degree angle here, right? This has to be a 90-degree angle. So draw a perpendicular to y-axis, and then keep going the same distance. If you find another point here, for every point on this graph, then we have what? We have symmetry with respect to y-axis. Now, we want to algebraically figure out, without graphing something, we want to figure out whether the graph is symmetric about the y-axis or not. How do we do that? Well, think of this x. If this is x, that has to be negative x, right? And then this point right here on the y-axis, that point is really f of x, right? It is also what? The same point is f of negative x. So that's it, you see. So we say that if f of negative x equals to f of x, then we say that f of x is an even function. Even function. Now, even function also means that the graph of it, can also say that the graph of f of x is symmetric about the y-axis. Okay? So that's the idea of even function. Now, an odd function is a function that is symmetric with respect to the origin. So let's say we have a graph that looks like this. Right? So here's a point. Now, what is symmetry with respect to the origin? Symmetry with respect to your origin means that if you have a point on the graph and you connect to the origin, then if you go the same distance on the other side of the origin and there is a point on the graph, like in this case, see if I connect to the origin and go the same distance right here, I'll find another point on the graph. So for every point you can do that, you see, for every point you can do this. If this is true, we say that f of x is an odd function. Now, algebraically, how do we prove that a function is odd without actually graphing it? Well, let's see. This point is x, the x coordinate, and this x coordinate is negative x, right? Now this y coordinate right here is f of x, and this y coordinate here is f of negative x. So all we have to figure out is the connection between f of x and f of negative x. And we see the connection, right? You see it? These two numbers are what? So for example, if this one is 2, this one would be negative 2. If this one is 3, this would be negative 3, right? 3, negative 3, 2, negative 2. What do we call those numbers? Yes, opposites. So that means f of negative x has to be opposite of f of x. And opposite means you multiply by negative. And if that is true, let me write it here. If that is true, then we say that f of x is an odd function, right? Is an odd function. Here we go. Okay? Now also it means that the graph of f of x, is symmetric over the origin. Okay, so that's all, even and odd function. Now obviously, not all functions can be categorized into only two categories, because there are some graphs that are neither symmetric with respect to y, nor symmetric with respect to the origin. So those functions are not even and they're not odd. So we call them functions that are neither odd nor even. So now we can answer this question. All three of them. Without graphing, is this an even or odd function? Well, it's very easy to check. Just find f of negative x. What's f of negative x? Well, we substitute negative x for x. So 3 negative x to the fourth power. And we know that negative to an even power is just positive, and then x to fourth power. Now it looks like that's the same as the function that we started with, right? That's exactly f of x. So we just proved that f of negative x equals to f of x. So that means this function is even. Now what about this one? Well, let's see. What is g of negative x? Well, that would be square root of negative x, which is not f of x, right? So it's not even. So we know for sure, not even. Now, is it odd? Well, for this to be odd, this has to equal to negative f of x. Now, negative f of x is not that. Negative f of x is negative square root of x, which is not that, right? So that means this is not equal to negative f of x either. So we say that this function is neither odd nor what? Nor even. Okay, what about number 49? Well, let's say h of negative x, which is what? What's h of negative x? Well, h of negative x would be 1 over negative x plus 3 times what? Negative x. And that is negative 1 over x minus 3x, right? Now, obviously, this is not the same as what we started with. So this is not equal to h of x. That means it's not even for sure. Not even. Now, the question is this odd? Well, to prove that, we have to find out what negative h of x is. Negative h of x means negative of whatever we are given here. So let's put it in here. What's that negative? That's negative 1 over x minus 3x, right? And notice that that's exactly what we have here. So these are equal. So this function, when you graph it, is going to be what? An odd function, right? That means it's symmetric with respect to what? With respect to the origin. All right. So let's do a few more. Looks like I'm going to have to do another video for the other two sections. But let's do a few more. Let's say 63. It says for the following, write a formula for the function g that results when the graph of the given toolkit function is transformed as described. Okay, so this is, we're going to do 63 and 64. Let's do both of these. Okay, so the graph of a absolute value of x is reflected over the y-axis. Now, if you reflect a point over the y-axis, you have to change x to negative x, right? So that's the first change. We have to do that. That's what this says. Reflect over the y-axis. And horizontally compress by a factor of what? 1/4. Now, horizontally compress by a factor of 1/4. So what does that mean? That means we have to, we want to divide the x coordinates by 4. We want to multiply them by 1/4. If you multiply, factor means you multiply. So if you multiply the x coordinates by, let's say we have an x coordinate here, 1, 1. If you multiply x coordinate by 1/4, in the formula you have to, because you're dividing actually by 4, so in the formula you have to multiply by 4, right? Because when you multiply by 1/4, you're actually dividing by 1/4. So if in the points you divide by 4, in the formula you have to multiply by 4. So that means basically what you have is negative right? So that's the new formula for that, 63. That makes sense? All right, now, and that's, if you call this f of x, we're going to call this something else. We're going to call it g of x, right? All right, 64, the graph of the square root of x is reflected over the x-axis. Now, reflected over the x-axis means what? You change y to negative y. So let's write them over here. X transformations and y transformations. So what do we have to do here? It says is reflected over the x-axis. Is that we change what? Y to negative y. So we have to multiply by negative. Negative, let me erase that. So that means what? Multiply by negative 1. Multiply the right side by what? By negative 1. And then horizontally stretched by a factor of 2. Now that's horizontal. So a factor of 2 means what? If you multiply by 2 with the x coordinates, if you take the x coordinates and multiply them by 2, then in the formula you have to divide by 2, right? So remember, the original graph here is square root of x. So the new function is going to be what? Inside, you have to divide by 2. And outside, this is the right-hand side, you multiply it by negative. Now, it doesn't matter in what order you do these two. If you divide by 2 first and then multiply by negative, or multiply by negative first and then divide by 2. X divided by 2, doesn't matter. But if you have more x and more y coordinates, you have to do those in order and these in order that you're given. All right? So one more, and that is number 69. It says, for the following, describe how the formula is transformation of a toolkit function. You just have to say what happens. Well, again, this is how many transformations? 1, 2, 3. So this is a x squared parabola function that, so let's write them over here. Let's write what happens here. So in the x direction and the y. So x transformation is only what? Adding 1, that means what? Shift to the left by 1, right? By 1 unit. The y transformations are 2. First, you have to multiply by 4. So first is a vertical stretch, right? Vertical stretch. So you multiply by what? By 4. And then this is what? Vertical shift down. Vertical shift down. So minus 5. Right? Now, you have to do these in this order, but it doesn't matter in what order you do these, right? So this is only 1. So you take x squared. You can do this to it. Move to the left by 1. That means you add 1, right? And then do this. Vertical stretch by a factor of 4. Multiply by 4. And then shift down 5. It does matter, right, which one you do first. Because you see, if I do shift down first and then multiply the right hand side by 4, then I'm going to have to multiply that by 4 too. So the order does matter. In this one, this is not correct. This is the correct answer, right? All right, and one more, and that's 78. I think that was 78, but let's see. Do we have? Oops. So yeah, 78 says For the following, use the graph to sketch the given transformation. Okay, so we are given a graph and we want to transform it like that, right? Well, since we have all the points, all we have to do is just do whatever the transformation says here to them. What's the transformation? Move down 2. So we're going to move all of these down 2 units. All the points, they'll go down 2 units. You could just move down main points 2 units and then regraph it, which is going to look like that, right? This used to be here, now it's here. This used to be here, now it's here, right? This used to be here, now it's here. So basically, you move those main points and then regraph this. All right, so I'm going to stop on this point and I'm going to do a video for these two separately, okay? So I'm going to see you in the next video, okay? So take care of yourself and others, and I'll see you in the next video.